Ladies and gentlemen, we are going to decide whether a reaction is oxidation or reduction based on oxidation numbers. Hopefully you've already have the rules for oxidation numbers memorized. If you don't, we're going to kind of go over it here, and I would like to show you. We're going to do these ones here on the bottom first, and then we are going to go up to these guys up here. And in fact, I'm only just going to do a couple. I'm going to take a look at this one, and 16. So that's what we're going to kind of look at. Here's the deal. Oxidation number of oxygen is always -2. Okay? Oxidation number of hydrogen is going to be +1. There are some exceptions. Those are listed in your rules, but in this case, this is not an exception. So the overall charge of the whole compound is 0 because there's no charge on it. So if I do my math, I have 2 hydrogens, so it's 2, plus I don't know what sulfur is, so it's X. I have 4 oxygens with the oxidation number of -2, so that's -8, and that all has to equal 0. So we're going to do some math here, okay? We'll combine like terms, so this is X minus 6 equals 0, X equals 6. Oxidation number of sulfur is 6. All right, if we look at number 13, P's all by itself, P4, 0. If it's by itself, oxidation number of 0. UO3, all right, you know that the oxidation number of oxygen is 2, okay? And there are 3 of them, and the total charge is 0. So I'm going to say X minus 6, that's -2 times 3 because you have 3 oxygens, has to equal 0. What's the oxidation number of U? 6. That's not always the oxidation number of U. We'll do number 15. Let's take a look. So now I have 2X minus, oxidation number of oxygen is still -2. So -2 times 5 is 10, so minus 10. And that has to equal 0. So we do a little math. 2X equals 10. X equals 5. So now the oxidation number here of U is 5. Changes, okay? If we look at number 16, this is a little bit of an exception to the rule. Not exception, it's just a difference, okay? Oxygen still -2, hydrogen still +1, okay? So I'm going to say I have 1 hydrogen plus I don't know what sulfur's is, okay? Oxygen still -2. -2 times 4 is -8. But instead of it equaling 0, see that negative here? It has to equal -1. So now we do our algebra. So X minus 7 equals -1. So X equals 6. All right, so it's a little bit of algebra, but it's not too crazy. So now we're going to move up to the top to figure out oxidation reduction. I'm going to do this one, and I'm going to do this one and this one. These guys have multiple different things going on. I'm just going to deal with these simple ones. All right, I taught you oxidation is loss of electrons, but the oxidation number goes up. Reduction is gain of electrons, but the oxidation number goes down. That has to do with electrons. When you add electrons, okay, your charge is going to become more negative, okay? So it's going to go down. When you lose electrons, oxidation is loss, you're going to have a more positively charged substance. So that's the deal. But I just follow this. If I'm looking here, I have a reaction. Oxygen still will have the same oxidation number, so I don't really need to worry about oxidation number of oxygen. I want to worry about manganese. So if O is -2, okay, and there are 2 of them, what is the oxidation number of manganese? It's got to be 4. Okay, so it adds up to 0. In this case, if we do the crazy math again, okay, 2 times manganese minus 6, I get that because the oxidation number of oxygen is -2 times 3, has to equal 0. We do the math, 2x equals 6, x equals 3. Okay, so now the oxidation number of Mn is 3. It's going from 4 to 3. That seems like the number's going down. So guess what that is? Reduction. Okay, and I just look at the arrow, reduction. Let's try this next one. Hydrogen doesn't really change, okay, it's +1. Oxygen's -2, okay, oxygen's not going to change here. So what would chlorine be? Has to be +7 in this case. 8 minus 8 equals 0. So it's +7. What's chlorine in this case? Hydrogen's still +1. Now this is -1. So we're going from +7 all the way down to -1. We're going down. You know what? Look at that arrow. Reduction. All right, next one. There's no charge, and it's all by itself, so the oxidation number of oxygen in this case is 0, but here it's -2, like normal. Oh, 0 to -2, we're going down. Guess what? Reduction. If the number itself went up, if it goes from 0 up to +1, like for example, this, Na to Na +1, okay, guess what? That's going up, okay, because that's 0 to +1. If it's going up, that's oxidation. That's a brief explanation of how to determine whether something is oxidation or reduction and to determine oxidation number.